Let's dive into the basic neural networks with TensorFlow. Let's first start with building a simple feed-forward neural network. This is a 10-step process, so it's pretty easy. It might sound confusing because of the names, but let's go dive into it. Building a simple feed-forward neural network involves several steps, including defining the architecture, specifying the input and output layers, configuring the hidden layers, selecting activation functions, specifying the loss function and optimization algorithms, and training the model. Here's a step-by-step guide for building a simple feed-forward neural network using TensorFlow. So first thing, import the TensorFlow. Start by importing the TensorFlow library, which provides tools and functionalities for building and training neural networks. We say import TensorFlow STF. Next, define the architecture. Deciding on architecture of your neural network, including the number of input features, the number of hidden layers, the number of neurons in each hidden layer, and the number of output classes for classification tasks. Here is an example. What you do is input size equal to 784, hidden size 124, output size equal to 10. Now, when you say input size 784, there's a number of input features, example pixels in an image. Hidden size is 128, number of neurons in the hidden layer. Output size 10 is number of output classes, example digits 0 to 9. Next step is specify the input and output layers. You define the placeholders for the input data X and the corresponding labels Y if you are working on a supervised learning task. You say do this like this, X equal to tf.placeholder. Provide the way tf.float32 is what I'm using, shape equal to none, input size. Y equal to tf placeholder tf_float, shape none, and output size. Step number 4 is configure the hidden layers. Define the hidden layers of your neural network, specifying the number of neurons and the activation function for each layer. You can do that by saying hidden layer equal to tf.layerDense, inputs equal to X, units equal to hidden size, and activation is tf.nn.relo. Step number 5 is specify the output layer. Define the output layer of the neural network which produces the final predictions. The output layer typically has no activation function for regression tasks but uses softmax activation for classification tasks. Example is output layer equal to tf.layers.dense, so input equal to hidden layer, units equal to output size. Step 6 is define the loss function. Specify the loss function that measures the discrepancy between the predicted outputs and the actual labels by saying loss equal to tf.reduceMean, and the first parameter is tf.nn.softmax underscore cross entropy underscore width underscore logits, and you provide labels equal to y and logits equal to output layer. Step 7 is select the optimization algorithm. In this, choose an optimization algorithm to minimize the loss function and update the model parameters, weights, and biases during training. Here is an Adam optimizer for gradient descent. Optimizer equal to tf.train.adam optimizer. Learning rate is 0.001. Next is train op is optimizer.minimize loss. Step number 8 is initialize variables. Before training the model, initialize the variables using a TensorFlow session. You can say init equal to tf.global variables initializer, then with, so starting a session, you can say with tf.session ss/run init. Step number 9 is train the model. Run the training loop to optimize the model parameters using the specified optimization algorithm and loss function. In this example, here is an example training loop to replace with your data. For epoch in range, number of epochs, perform forward and backward pass. You can do that by saying current loss equal to session.run train op loss comma feedback feed dictionary equal to x input data and y is target labels. Print the training loss by saying print epoch plus 1 and loss equal to current.loss. Step number 10, the last option, is evaluating the model. This is an optional step. After training the model, evaluate its performance on a separate validation or test dataset to assess its accuracy and generalization ability. You can do that by saying accuracy equal to session.run. You pass the accuracy operation as the first input, then feed dictionary equal to x test data and y equal to test labels. print the test accuracy, and you'll get the accuracy options. By following these steps, you can build a simple feed-forward neural network using TensorFlow. Experiment with different architectures, activation functions, loss functions, and optimization algorithms to optimize the performance of your model for specific tasks. Adjust the hyperparameters such as learning rate and batch size to improve training efficiency and convergence.